Hi class, this worksheet here is designed to start your studies for the Chapter 7 and 8 test. Some of these problems are a little bit more straightforward, and towards the last half you're getting to the intermediate level kinds of problems. So it starts out a little easy and then it gets to the middle level, a little bit hard. But I wouldn't only study this sheet. I would say this is the beginning of how you study. And what I'm going to do with this time that we have here is I'm going to solve for you and explain the solutions to the even ones. And I do encourage you to go ahead and do the odd ones as well. And the answers are at the back. So you can check your work on the odd ones. And if you are not getting the correct answer and don't know why, then we could have a follow-up meeting, or maybe you could email me or something like that. But I do want to encourage you to do as much practice and study as possible for this test. So we're going to attack the even problems here. And we'll start with number 2. And so number 2 is requiring us to remember a certain formula. So we're imagining a circle here. And they told us the radius is 4. And we're drawing an arc on the circle. So let's say the arc goes from here around to here. We don't know exactly. Now, conventionally, we will call the arc S. And they told us it's 2 pi meters long. So it's about 6.28 feet long. It's wrapping around the circle. I'm sorry, 6.28 meters long, where the radius is 4 meters. Now they want us to find this angle, and that 4 on top is confused me. I don't want the 4 there. So there's some angle here, theta, and our job is to find the theta. And we've got to find it exactly. All right, so there is a formula. When you have the arc and the radius and the theta, there's a formula I want you to remember. S over R equals theta. And there is one caveat if you're going to use this formula, and I hope you're remembering what that is. The formula only works for theta in radians. Now, as an aside note, the formula also says the arc distance is r times theta, also in radians. But we don't need the second version of the formula. The first one will be fine. So I'm going to plug in everything I got. I've got 2 pi is the arc, and 4 is the radius. So the angle is pi over 2. That is exactly the angle that is made by a arc. So this arc here, when it spans around, this actually goes pi halves, and they ask for that as well in degrees, which is 90 degrees. So we got both answers there. So the big theme about this problem is remembering this formula. That's an important thing. It's just remembering its connection and how to use that. Let's jump down to number 4. Find 4 angles in different quadrants with the reference angle of 40. Okay, let's go to the coordinate system. And we'll draw an angle. 40 is just shy of 40 degrees. 45, I mean. There's my theta. Now, we want 4 angles in different quadrants with the reference angle of 40. Well, the reference angle, let me change. If theta is 40, and I'm in quadrant 1, I think I want to do color here. So quadrant 1, Well, quadrant 1, the reference angle and the original angle are the same. So if the purple one, let me get this consistent here. I'm going to call the purple one the reference angle. And the black one is an angle in one of the quadrants that is the same as the reference angle. Okay. But they want 4 of these in different quadrants. So let's figure it out. What is it in quadrant 2? So the angle would have to be over here in quadrant 2. And so this would be my theta in quadrant 2. And it's going like that. But it has the same reference angle. So if it has the same reference angle, this part of it here is 40 degrees. And so we can use that to figure out the quadrant 2 angle. And it might be all coming to you, or you might already have it. But it's going to be 180 minus the 40, which is going to be 140 degrees. Well, we can keep doing this because now there is quadrant 3. So if I come over here to quadrant 3, this time I'm looking at theta that goes like that. And that is a quadrant 3 theta. Now, it has the same reference angle. So if this is my reference angle here, 40 degrees, it's mirrored here. This is also 40 degrees. So if I want this quadrant 3 reference angle, the quadrant 3 angle, it's going to be 180 to get this far, plus this extra little piece, that little purple piece. So that angle will be 180 plus 40, which is 220. And then we will need one more solution. So this time, it's getting congested here, but we need a quadrant 4 angle. So here's theta. It's in quadrant 4. It doesn't look like a Roman 4. And if it has the same reference angle as 40, then geometrically this part here is 40 degrees. And so if I want this angle here, all I need to do is take part of the circle, and this extra little piece of the circle is 40, so that makes a complete circle, which is 360. So if I do the 360 and subtract off the 40, I will get 4 angles. So I got 4 different angles. They're all between 0 and 360, and they all have this reference angle of 40. So that is an important problem about just refreshing ourselves and remembering how reference angles work. A similar one to that is number 6. To come up with the reference angle for 7 pi sixths. Some of you can tell right away, and if you can, just speed through and get it. But some of you need to think about it a little bit more, or some of you may be more visual and you kind of need some clues. And one of the clues that I need to see to help me visualize where I'm at is I start with an angle. I start with 180 degrees, but in terms of radians, it's a pi angle. Now I make pi into fractions, And I want the fractions to be fractions of 6 so that it helps me compare what I have to what I got. And I've got 6 over 6 pi. And I see 6 over 6 pi is not big enough for 7 pi sixths. So I've got to make it go a little further, but just a little bit further, because I didn't draw it very proportionally. But I have to go from 6 pi sixths to 7 pi sixths, which means that this part of it is the reference angle. And I can find that simply by subtracting. Now I know that a lot of you can do that in your head. 7 pi 6 minus pi 6 pi sixths. So I'm taking the top half and subtracting it off 7 pi sixths to find this reference angle part, which is pi sixths. And since we started in degrees, we're going to find the reference, since we started the angle in radians, we're going to find our reference angle in radians. Alright, another quick little one. Like I said, it starts out kind of easy, so these first few problems are very basic kind of review problems. And so we want to turn 4 pi thirds into degrees. Now you might recall that pi equals 180 degrees. And with that we get two fractions we can make. Pi over 180. And we get another fraction we could make, 180 degrees over pi. And both of these are 1. They are fancy versions of a ratio 1. And because they both equal 1, with quotes around it, we can multiply it and it doesn't change anything as far as the values. But the ratios will change the name of the fraction, just not the value of the fraction. So if I take 4 pi thirds, I'm going to use one of these to make degrees. So I need degrees left in the end of this work. And the only one that's going to do that is the green one. If I take 180 degrees over pi, and when I multiply, the pi's cancel and the degree unit is left. So a little bit of reducing here. 3 goes into 180 60 times. The pi's have canceled. 4 times 60 is 240 degrees. So we've just changed the 4 pi thirds into degrees. And the thing to remember here is our multipliers. These two ratios do our conversions for us. Okay, so now we're getting into some problems that are going to make us think a little bit more deeply than the ones before. They're asking us to write an equation, and we've got a few facts. It's a periodic function, so that's just another way of saying it's a sine or cosine. It has a midline at 4, an amplitude of 5, and a maximum value at t equals 0. So, I'm visual. You may be visual, you may not. Maybe you're analytic and you can do it without a picture. But I think for the benefit of lots of people, let's draw a picture here. So here's 0. And it has a midline at 4. So let's put our midline right about here. I don't have a whole lot of space. Okay, now that would need to have a 1, 2, 3, 4. And we've got an amplitude of 5. Okay, well, amplitude is the measure from midline. So if I'm in the midline of 4, my amplitude is 5, I'm going to have to go up 1, 2, 3, 4, 5 units up here to 9, and that makes the top of the window. And if this is 4 for the midline, I'm going to have to go 1, 2, 3, 4, 5 down to -1 for the bottom of the window. So if I create a window for one cycle, I'll have a pretty good sense of an equation. And so I'm going to make a different color for my window here. Let's make it orange. So it has to go from -9 to 1. Now, what about the period? What about the period? The way the equation is constructed, we have t here. That's our variable. So our axis is not the x-axis, it's the t-axis. And we do not have a coefficient. It's not saying a sine of b times t. So they're just using t only. And that means we can imply from that b equals 1. That doesn't look good. Okay, so that means the period 2 pi over b, which is 1, which is a period of 2 pi. So if I finish my box over here, I'm just going to randomly mark it 2 pi. My box will have to come out here and finish. So I've got a box, a window for my cycle. And all I need to do now is kind of finish it off, but there is one problem. They told us to write down a sine or a cosine. And we need some more information to do that. And there is one more clue that we haven't used yet. It's this one here. The maximum value happens when t is equal to 0. Well, based on the amplitude and the midline, the amplitude is 5, the midline is 4, the maximum value is 9. We figured that out already when we drew the window. So when does the maximum value occur? When t equals 0, I am at this max point. Okay, so if I'm at the max point here, that forces a certain conclusion. Which wave is it? Sine or cosine? Well, cosine is the only one that starts on the maximum point. Sine always starts in the midline. So if I had a sine, I'd be starting here on midline, hitting the midline at the middle and ending at the midline. But this graph isn't doing that. It's starting at the top. So I'm going to have to use the cosine graph to satisfy all of these requirements here. So we figured out the amplitude, that is 5 cosine times cosine of t, and the midline is plus 4, and that equation is the equation that satisfies the conditions here. Right, let's do this again. It's a similar problem. The last one was giving us numeric information and we turned it into a graph, and then from the graph we got the equation. This one is similar because it's a graph and we got to turn it into an equation. So let's see if we can figure out what equation we have here. And in order to do that, we need amplitude, period, phase shift, vertical shift. We need all that data. And you can start tracking down that data if you capture a window. And so it turns out here, this window has a complete cycle in it. Starts at the bottom, ends at the bottom. That's a complete cycle. So whatever it is, that window is going to work for me. So let's start identifying what we know. The amplitude. The period. The phase shift. That one's easy. The box is on the y-axis. Phase shift is 0. Is there a vertical shift? Yes, the vertical shift. The midline is at 6, so it's been shifted up 6. All right, well, wait. If this is 6 and this is 0, what's the amplitude? Well, the amplitude is the distance from the midline to the top or the midline to the bottom. It's the same distance either way. So the amplitude is also 6. Now, what's the period? Well, they only gave us one little clue. They gave us this 3 for the x-axis or the theta axis. And 3 is halfway. So it's got another 6. So the period has to be, if this is 3, then the whole distance has to be 6 units on the period as well. All right, so we got to translate all of this stuff into an equation. Now we need one more little fact. What kind of wave are we looking at? The wave, it starts at the bottom and ends at the bottom. Well, just like we did a minute ago, if it was a sine wave, sine starts in the midline, ends in the midline, and the middle is in the midline. This is not a sine wave. This is a cosine. Actually, it's not a cosine either, not purely, because it's been reflected. Reflection. We have a reflection to deal with. Okay, so here's what we're after. A cosine of b theta plus c plus d. That's what we got to track down. Okay, so the amplitude is 6, but there is a reflection, so that means A equals -6. The phase shift is 0. The period is 6. Let's do period and translate that into B. 2 pi over B equals the period. Well, we don't know what B is, but we know the period equals 6. And if we solve this, we will get the B number. Little quick algebra here, multiply by B. And then I'm going to have 2 pi equals 6B divided by 6. And so B equals pi thirds. There is another formula for phase shift, which is C, but it equals 0. So -c over B equals phase shift. And phase shift, we can take that out and plug it in and solve. If we needed to, we could plug in the B and do the calculation, but it's going to equal 0, and the only way it equals 0 is if C equals 0. So I'm kind of being lazy on that one, but that's a little bit direct. C has to equal 0. So we have the A and the B and the C, and the D is very direct. If there's a vertical shift of 6, then D has to equal 6. So that gives us all the constants and coefficients we need for our equation. So y is going to equal -6 cosine of B, which is pi thirds times theta. C is 0, I don't need to put that on, plus 6. And there's my equation. Okay, let's go down here to number 14. So on 14, we're having an equation, and we're going to pull out the information of the equation so we could graph it, if we had to graph it. But it's not really asking for all the graphical details, just the parameters that make the window. And so let's start here with, we've got a equals -5, b equals 2, c equals 10, d equals -2. Let's take off the easy ones right away. D equals -2. That's a vertical shift. So the vertical shift is -2. We're going to go down 2. The amplitude, true or false? Amplitude equals -5. True or false? I hope you're thinking false. Amplitude is never negative. Amplitude is always an absolute value number. So we always go the absolute value of that. And that is just the distance, not the up or down part of it. So the amplitude is 5 units up. The last two we have to do a little bit of work for. The work for period is the easiest. It's got one variable in its formula, 2 pi divided by b, and I can plug that in. So period equals 2 pi divided by 2. Maybe I should have put the arrow here. And so period equals pi units. So we got our period figured out. Lastly, phase shift. Phase shift or horizontal shift is -c over b. And so let's see. B we just calculated. We can plug that in. So if we, and C, we can plug that in too. Oh no, we didn't calculate B. We have B and C. We can plug in both of these numbers here. So negative of C is -10 over B, which is 2, which equals -5. So there's a phase shift, and it's 5 units to the left, -5. Now intuitively, you might have recognized that if we're adding on inside addition, that means it's shifting. That means we're shifting to the left. When we have a +10, that plus means it goes to the left. And that's where -5 is starting. It's starting on the left side of 0. All right. Let's see. Number 16. Let's do some inverse trig function calculations. Now remind me, this is the same as cosine inverse of a half. Now this input and this output, what are we looking for? The input represents something and the output represents something. The answer output is what you got to find. And the input represents something too, and if you understand what it represents, it makes it a lot easier to know what you're finding. The input of an inverse trig function is a ratio. The output is an angle. We're looking for theta. So we want an angle so that the cosine of the angle equals a half. Now you can, there's a couple ways you can do that. You can say, oh, it equals theta, and you can convert the problem around by flipping it, and then maybe that will help you connect to your memory, what you've memorized with the angles and stuff like that. But that's a 60-degree angle. So the unknown angle that we're after is 60 degrees, except for the fact that they said we need a radian. So we're not going to say 60, we're going to say pi thirds. Okay, another one. Cosine arc cosine of -1, it's the same as saying cosine inverse of -1 equals. And just like before, the output is an angle. And we're trying to figure out what angle it is. Now, if you've memorized the 0, 30, 45, 60, 90s, that might help you, but those are going to be all positives. And with the negatives, a little bit more challenging. So if one of the things that helps for me sometimes is I switch it around. I swap the inverse function back to cosine. And then I think, okay, that's the ratio, that's the -1, and you can use the unit circle to kind of give you some clues. Because on the unit circle, you got points on the circle, and every point on the axis is a 1 or a 0 coordinate. And every point on the circle is either a 1 or a 0 in my coordinates. And this one is a -1, 0. And that one is a 0, -1. And then I look at, I'm going to move this over. It's that point down at the bottom at 270 is 0, -1. And I look for which one of these is cosine. Well, cosine always corresponds to the x coordinate. That's the only x coordinate that works there. So that angle has to be 180 degrees. So there's kind of a little analysis that you could have done if you needed help with that one. And then lastly, arc cosine of 0.1. That one is not one that we've memorized. The only way to do that one is by a calculator. Now, I'm going to poke it in the calculator really quick here. All right, I wrote down 2 answers for you. And when you work it in the calculator, it's likely that some of you got one and some of you got the other. And I want you to be smarter than your calculator and really pay attention to what's happening here. Remember, this is a ratio input. So the input is a ratio. And the output is an angle. So one of these two is the correct angle, and one of them is an incorrect angle. And it's incorrect because of the context. But the context said it had to be in radians, so you got to be paying attention to that angle. And your mode in the calculator has to be right, so this one turns out to be incorrect. And the radian angle is the 1.47 radians. All right, so that is kind of a quick overview of some of the even ones to practice. And I have a little bit of extra time. I'm thinking of doing number 15, which is one that we have not seen a whole bunch. We haven't seen tangent graphs. And so I think this one will be good for us to kind of develop so that you have a sense of how to do a tangent graph. Alright, so let's do a quick review of a quick sketch of tangent. Because this graph has a shift. That's all we have to deal with, is an inside change of -π12. So an inside change is a horizontal shift, and that's all that we have to transform. So if we can remember a quick sketch for a basic tangent, then we can transform it or shift it pretty easily and be done with the problem. So let's do a quick review of how to graph y equals tan of x. Now for sine and cosine on the x-axis, we always start our window on the y-axis itself. Should be a little lower there. and then sine hits the middle and goes up and down, or cosine starts at the top and it goes down and then up. But tangent, it also has a window, but the origin, unlike sine and cosine, the origin is in the middle of the window at the beginning of the window. For tangent, the origin is actually in the middle of the window. And we have a cycle length of pi. So the period of tangent equals pi, not 2 pi. Same with cotangent. The period of cotangent is pi. They both have a shorter period than sine and cosine. And we also learned before that there's a couple asymptotes. So if we put these asymptotes here, oops, I didn't get my color here. If I put my asymptotes on here, this is going to make my window. So I have negative pi halves to positive pi halves, and those are two asymptotes. And notice what I was talking about. The 0 is in the center of the frame. And that's one of the target points. Now if we take pi halves and cut it in half, we're at pi fourths, which is 45 degrees. Tangent of 45 degrees is 1. That's one of the targets. If I come back here and I do negative pi fourths, that's negative 45, which is in quadrant 4. So tangent of negative 45 is negative 1. Those are the tangent's 3 targets. And then we also have the asymptotes on either edge. So when we graph tangent, it's going to start out at negative infinity, come up, 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 and up. So that's a quick sketch. So if you can make a quick sketch, then it's just a matter of making the right transformations to graph. Okay, so for this problem, all we have to do now is figure out what's happened. The negative pi halves is in the inside, so that means a horizontal shift, and it's negative, so it's going to be a horizontal shift to the right. So all of these points over here have to move right. So if I move them to the right pi halves, that means this asymptote that used to be, for the standard tangent, I would have an asymptote here at pi halves. But it just so happens to be the same as the shift number, so I'm moving it to the right. So that first asymptote is now going to be at 0. The other, well, let me put them both in here. So this is the quick sketch asymptotes, negative pi halves and positive pi halves. But because of the shift, this one's moving to the right pi halves and that one's moving to the right pi halves. So I'm going to shift everything over, and so the asymptotes are now shifted to 0 and to pi. Now, when I look at the window, instead of before, the origin was in the center, but it's moved now to pi halves units over. So my target points are, this is 1 and negative 1. These are my 3 target points. So I had those same 3 target points, they're just shifted over. So they've just been moved over pi halves units. And so the graph then is going to come off the asymptote from negative infinity up. And there is a quick sketch. So let's see. Asymptotes. It does say to identify asymptotes. So we have 2 asymptotes. X equals 0 and x equals pi. And identify intercept points. So we have an intercept point at pi 0. No, that's not right. It's right here. It's pi halves. And so that covers it. We got a quick sketch. We answered a few details about it. And so now we've got a little practice graphing tangents. Hey, this is just the beginning of studying. I really want to encourage you to work hard on this test. It's a big one for us. If you can really break through here, you'll be in great shape for the rest of the course. So I want to encourage you to study really hard. Okay, well, have a great day, and I'll see you in class next time.